Saturday morning. Okay, and while we are waiting for my ESXi server to boot, we are going to discuss wildcards. Now, wildcards or the reverse mask, okay, all right, or the opposite of your mask, however you want to call it. A wild card is set up. Ooh, that's small. Um, Matter of fact, let's do it this way because I'm already prolonging the video. All right, so let's go here. And let's change this to 26. Okay. All right, so that's not going to work. So let's put a character in there. Shift. Okay. Right click and 26. Okay. So we're going to start off with two different wildcard masks. Okay. Now, how do I want to do this? Let's. Okay. So let's do it this way. Okay. Exact. Okay. Did I even spell that right? Spell that right? Who knows? You guys can call me later on. Okay. And nothing. Okay. So I need you to understand two things. When you learn something, okay, especially like wildcard math, all right, you're going to learn examples, okay, in order for me to explain it as I'm going through this, okay. Now you're going to probably memorize those examples to pass an exam, and you're going to memorize the examples, okay, to do your job. All right, that's not you understanding wildcard math. That's just you remembering and pulling from memory. Okay. Only one time have I tried to explain the power of the wildcard mask. Okay, from a bit by bit perspective. Okay, and it fell hard. Okay, so hard that the misunderstanding of the people that I was explaining to it were coming up with like, WTF, like what the fuck. Okay, all right. These are individuals that they're not ready for it, but here's the reality of it. I can say that all day and say I'm smarter, but that's not the case. The case is I had failed to explain to them, okay, the power of the wildcard mass. Okay, so with that failure, I'm going to delete the post and let them just go back to doing what they're doing. Okay, because that could be more harmful than anything else. Okay, all right, making them make more mistakes, or at the same time, be honest, it's just one topic. I got so many other topics that I could talk about. Okay, all right, but what I want you to understand, okay, is how powerful it is. Okay, so, uh, 192 to 168. This is crazy. All right, let's first of all, let's okay. Let's go to home. Okay, 20. So let's make this 26. Okay. So now let's delete this. I don't think it's gonna work, and it's not. I need to go into I need to go into my options. Okay. All right. We're just gonna do it this way, because I'm not gonna be changing the font every time. So let's go home and OneNote, um, default font size. Okay. File option. I see. I was looking for options. I didn't see it. File options, default font. File. Do you see options? Okay, this is what trips me out. Unless I am tripping here, I don't see options. And here's options over down here. So yeah, I was tripping. Okay. So display general. Here we go. Okay. All right. Still was wrong from the perspective of getting me there literally, but hey, it doesn't really matter. Okay. So now it looks better. Okay. So 192.168.5.7. Okay. If I take this IP address up here, okay, and match it with a 0.0.0.0, that is saying because every octet in here matches the octet of the numbers you put before it. Okay? So a 0 means exact number. Okay? And what does that mean? So that means we go to here. Okay, let's do it. Let's do it 4. Okay. Actually, we gotta do it. We gotta do it different than that. Okay, so let's delete this. Kind of trying to articulate in my brain how I'm going to do this. Okay, so 128, 64, 32, 16, 8, 4, 2, 1. Okay? Alright, and then 0, 0, 0, 0, 0, 0, 0, okay? And we'll just do another one as well. Okay, now, exact means, okay, that 192 equals what? Okay? Alright? So, bit 128 and bit 64 from a so-called value of that bit perspective, okay? That is what equals 192. Okay? That means if I put a 0 in the wildcard mask, that means I am not changing. I don't want any of the bits in that particular octet of the number that I had typed before in my command line to change. That's what 0 means. Do not change any of those bits in that octet. Okay, so that means the number must be 192. Okay, if I put this number here, okay, as a 255, okay, it says in that octet, okay, all right, whatever octet we're at, all right, it I don't I don't care what the bit is. It could be anything. Okay? Alright? So let's look at it from this perspective. Okay? Alright, so we're gonna actually say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Alright, and we are going to build all these. Okay? Alright? 1, 2, 3, 4, 5, 6. Nah, come on. 1. You know, can I do this? Can I do this easier? I mean, I guess I could have if I had created the table first, but nonetheless, okay. I'm just like, this is kind of tedious, but doesn't matter. Okay, you know how to fast forward the videos, so I get them all done. Okay, we're at 7. Oops. Come on. That is Shift Tab, by the way, if you want to go back. Okay, just in case you were curious how I did that. Okay, so now. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and that was not 10. Okay, So, hitting caps again. You know, I think I'm gonna disable caps for real. All right, so hang on for 1 second. Okay, so now we're gonna try to get these. I mean, can I? Let's do the draw. And can I do a line? I'm sure I can. I don't use drawing on OneNote. Here we go. Okay, so first of all, we are going to come down here. Okay. All right, and then we're go. Oh, come on, have it selected. I can't do that. Thinking that it's Vizio. Shame on you. Shame on me. No, I can't. Okay, so we're gonna have to move this line up here. Copy, paste. Okay, there's a reason why we're doing this. And it's not just to prolong the video. Alright, so here. Okay, so it was 10. Sweet. Okay, so we got our. Well, I mean, we could probably move this down a little bit. I don't want to move it that much. That's too much. So let's leave it the way it is, okay? All right. Obviously 4, which of course I can't even get in there, but nonetheless, okay. All right. It's obvious where 4 sits. Okay, it would be nice to get 4 probably. Yeah, see, it does. It's just not a good program to do this with. But Word would be a lot better, but it doesn't matter. Okay, we got our thing. So now, how do we write 1 in binary? Okay, okay, that's 1. Okay, that is 2. That's 3. Okay, that's 4. Okay, so all right, we can't. We have to change this. So 5. So 3. Let's move 4 down. Okay, so okay, that's the best we could do. Okay, so obviously we're gonna take this line and kind of move it a little bit below here. Okay, so we know 4, 1, 2, 3, 4. Okay, all right. So, and matter of fact, you know what we could do? We could color code these, but we don't need to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we got it. Okay, so 5. 6. That would be 4. And 2. Okay, and then 7. Then 8. Then 9. Then 10. Okay, now the more you deal with subnetting, okay, all right, and the 128, 64, 32, and series of numbers, okay, all right, and the binary counting like this. Nobody wants to do this, writing out all these bits and doing math. Nobody wants to do it, but it is crucial, okay, for the understanding of subnetting, for summarization, and for wildcard bits, okay. And most people don't really understand why this is important. So, what I want you to understand is if I look at these binary numbers, when I actually say, okay, let's say we're doing this as a wild card 0.0.0.1 as a wild card, okay, what I'm saying is the value of 1, okay, meaning that from a decimal perspective, 1 equals 0.0.0.0.0.1, okay, all right, that saying that means that any number that has the number 1 value bit set to 1 match on that number. Okay? That means, what does that really mean? 0.0.0.1 as a wild card. Okay? As a matter of fact, before I say something, okay, I tell you, I want you to look at the bits, okay, and look at the numbers and see if you see a pattern of what's turned on in the first value number, number 1, okay, this row here, okay, is there a pattern that you see? Okay, all right. Now we're gonna go to our switch, okay, and oops, and apparently we're gonna. Oh, I didn't. you know, you gotta turn it on, Kyle. All right, so okay, and let's go ahead and turn this on, and turn this on. Okay, all right. Now I'm going to if okay, so I'm gonna let you look at this. Well, apparently not. Okay, all right. Let's bring this down. Again, look at those numbers. Okay, all right. Once again, all right. I'm gonna cover it up, so I apologize. But all right, do you see a pattern? Okay, all right. Now there's two patterns I see: 1 0 1 0 1 0 1 0. But from left to right, do you see a pattern? Okay, all right. And now the pattern that I see, okay, is that every odd number has a 1 turned on in that bit. Now you gotta understand something, okay? As we are doing binary and converting it over to, um, or I'm doing from decimal over to binary, okay? We're kind of going from right to left, but okay, as we're doing our math, we can only go from right to left, turning on bits. Okay, so a value of 1, okay, means that, okay, 1 is 0.0.0.0.0.0.0.1. In case I had too many zeros, I apologize. Okay, so now, um, let us go to security. Okay, so now our JCC is up. Perfect timing. Okay, all right. Enable. Oops, enable. Show IP interface brief. Up. Show IP route. Okay, all 255s are in here. So now I'm going to go under the router EIGRP list. Before I do that, I'm going to create an access list. Access list. Okay, and I'm going to say, okay, um, I'm trying to figure out how do I do this. Access list 1. Okay, and we're going to permit. We got to permit it. Okay. Now remember, everything after that is going to be an automatically deny. So we don't have to put anything else in there. Only permit. Okay. Um. Hmm. Can I do this? with a wildcard of 0.0.0.1. Okay, or do I have to do 255s? If I do 255, because 0 would be matching. Okay, so let's try this. Okay, so now I'm gonna go under the router process. Okay, router EIGRP. Okay, now you know we have every octet in here. Okay, odds and evens. Okay, now I'm going to say distribute list. We can do this in OSPF. We can even do this in BGP in OSPF. Sorry. Okay. So this is a standard command. Distribute list access list one inbound. Okay. We got to understand what that means. As routes are being learned in on my router, okay, because each router is its own entity, okay, that's how we're going to distribute that list. Okay. Now, all right. Once I do this, we have to wait with ERGRP until, okay, or I can just clear the ERGRP process. Okay, there we go. All right, neighbor 1.2 is resynced. Show IP route. Okay, did not work. Okay, did not work at all. So let's go in. Config T. Let's say IP access list 1. Okay, standard 1. Okay, and say okay, we're going to say no one. No one. Okay, and now this command here is still not under the IP access list. Okay, this is a global configuration command. Okay, and we're going to say 0.0.0. Okay, all right. Notice it took me back to the global configuration command because this is not a command that you would do under the access list. Okay, let's wait for EIGRP to resync. Okay, all right. Still, okay. So now, okay. Wait a minute. Oh, okay. Um, so let's. Okay, that's probably why. Okay, so let's say um, no. I say no IP access list standard 1. Okay. All right, and then let's do this. Do show access list. Okay. And now let's see. Wait until it resyncs. All right. So obviously, I need to go back on this particular uh, uh, method of doing something and reteach myself this because I'm failing at the moment. So let's see if we get it this time. No. Okay. So at that point, we're done. All right. So all right, I'm gonna go back and do my own research. Okay, to figure out how we do this again because we try. You know what? Let's try. It shouldn't matter. Okay, because I'm not getting any EIGRP routes. And we're going to try this one more time. Wait until it resyncs. Okay, so no, it's not working. Okay, so we're gonna stop the video, call it a failure, and then we're gonna come back with a new video and try to figure out what's going on because obviously this has escaped my mind. But what we're trying to do, okay, is say out of all the IP addresses, okay, all right. Wait a minute. Let me rethink that. Let me rethink that. Do I have to put a one in the last octet? And not to mention the fact we're not even matching on the last octet. We're matching on the third octet. Okay, so we got to change that. Um, yeah, 255 has a one in it, so it should work. Okay, so but we are matching on the wrong octet. So let's try this. Okay, and let's change this. Okay, all right, and waiting for it to resync. No. Okay. Oh, it just changed. So still no. Okay. Um. So let's try it this way now. As I'm trying to articulate and figure out how to do this. Okay. So no do show access list. Okay. All right. So now let's go here. Let's go back to the beginning and let's say access list. Okay. And let's say 1 0. All right. Okay. So now no. Okay. Okay. So let's get rid of this. Okay. Oh, stop. 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 Okay. All right. Stop. I know what I'm doing wrong. Okay. All right. So, first of all, these are 255s. Okay. And I'm saying that we're going to match the number 255, which we don't have in our IP address. Okay. All right. So, first of all, do show IP access list. I see my mistake now. Okay. All right. So now we're going to say, okay. So this is not going to be like this. Okay. This is going to be okay. Because the third octet, I want everything that only has a one in it. Okay. The bit turned on to one, so it can be 255s. Okay. Okay, and then 255 dot 255 dot 1 dot 255. Okay, all right, because we're only matched on that third octet. Now let's see what that does. Let it resync. Okay, so show IP route. Oops, come on. Okay, now check that out. We got some EIGRP routes. Okay, all right, but we're only getting 4 and 5. All right, so let me go ahead and pause this and think about this for a second, and let's come back with the logic. Okay, I had to go to the bathroom, so let's see now. Okay, so let's think about this logic. Why am I only pulling 254, 255? Because I had put 255 in the beginning. Okay, remember I had put 255 Okay, and my wildcard was 255.255.1.0. Okay, or 255. Okay, so here's the thing. If I am pulling 255 to 255, okay, all right, we should not do it that way, okay, in the first octet, all right. Now that shouldn't matter, but it does matter because we're also saying in the first two octets, I don't care what it is, all right. So let's go back. That which means is I'm not just pulling, okay, the IP addresses that have the one in that octet, okay? Because I want to pull odd numbers, okay? So let's only odd numbers. So let's go back into here, okay? Say no. Now I'm gonna try this again, okay? Now this is common, guys, okay? You have a project to do this, okay? This is what you're going to do in your lab, okay? Are you trying to figure out what the proper mass is supposed to be, okay? All right, because 9 times out of 10, unless you can find a, you know, a documentation on how to pull all odd numbers, which you can. Okay, Cisco has that documented. Okay, or even a calculator. Who knows? All right, so now I'm going to say we can't say zero though. Yeah, we can. I'm sorry. Or can we? Because zero equals zero, which is all bits off. So what if I do? Hmm. Because I'm saying I don't care about the wild card in that particular one. So dot dot. The third octet has to be a value of 1. Okay. And this has to be 0. Okay. Alright. Or hold on. The first octet is 0. We do we don't care what's there, we don't care what's there. Okay? The last octet we don't care. Alright, we have to set a 1 in the third octet at least because that bit will not be turned on if we put it as a 0. Okay? 255 from my perspective would have worked. Because it's an odd number. Okay. Alright. Alright, so now let's try this. Yeah, guys, I'm just guessing. Okay, so it's obviously this is not embedded in my brain. I gotta refresh my memory. What if we make this as 255? But see, that would be the value of that. Would be turning all those other bits on. That's what's confusing to me. No, I could say 255. It doesn't. It does not matter. Out of all those bits, okay. Okay, so let's do a no. Waiting for it to resync. Okay. Okay. All right. So it's not working. Okay. Maybe I have to do it because remember, hold up. Okay, this is the third octet. Okay, maybe. See, here's the thing. All right, so let's just turn this off. Actually, we can just go to here. See, this is the one we want to match on. Okay. All right. This is not working. All right. So let's try this again. I have 0. I think this should be 255. 255. Any bits in those octets doesn't really matter. Okay. 255. Okay. All right. The first two octets doesn't matter. The third octet needs to have the value of 1, meaning that that bit 1 has to be turned on. That should work. To me, that's logical. And let's see what it pulls. And it's not pulling. Okay. Do you know what? These are slash 24s. These should be host IP addresses. What's going on here? First of all, oh, I made them all. Okay, that's the problem. That is the problem. Okay, these should be host IP addresses. So first of all, let's do a Control H. Okay, and we're going to say 255.255.255.0. Okay, and we're going to replace that with 255.255.255.255. Okay, and get rid of that. All right, replace all. Okay, so good. That does that from the entire document. Okay, so now I'm going to actually just pull the first 20. Notice as I did not copy the last bit, instead of recopying again, I used the shift key and the down arrow. Okay. Oh, I'm sorry. God damn, Kyle. Shit. All right, so IP loopback. It doesn't really matter. I'm not advertising in the loopback, but the same thing. I don't want to come up in the no interface loopback one. I don't want it to come into my routing table. Okay, and luckily we only did 20. Okay, all right. So let's come back over to here, and um, okay, and let's add those in there. Okay, so now we are going to clear EIGRP 100 neighbors. Okay, all right, manual cleared. Let's go ahead and just that should be okay. Okay, so show up your route. Okay, yeah, it's still that's interesting. That's weird. I mean, for me, the syntax is correct. Okay, but apparently, but again, wild cards when you're being this granular, okay, something is off. Okay, so we failed. Ain't no big thing. Okay, there's gonna be many more failures to come. All right, in my studies and yours. Okay, so we just move on. We do our research and we make that weakness back either back up to par. Okay, or make it a strength. I'm not really a big thing about making it a strength. You know, as I do my air quotes. I'm more of bringing it to a particular level of understanding. Okay, all right. It doesn't have to be a strength. Okay, because if I make something strong as a strength, okay, all right, and it's a piece of technology that's not something I'm going to utilize or actually deploy or manipulate on a regular basis, making it a strength, that strength is going to be lost over a period of time because if you don't use it, you lose it. Okay? So, nonetheless, we got a failure, we move on, and I'll see you guys on the next one.